What if the strangest helmet ever seen in nature wasn't made by humans, but by an insect no bigger than your fingernail? Deep in tropical forests lives a bizarre creature called Bocydium globulare. At first glance, it looks unreal. Its body is small and compact, but rising from its back is a structure that resembles a delicate scaffold of spheres balanced on thin rods, almost like an alien antenna system. This structure is not random. It is an extension of the pronotum, a part of the insect's exoskeleton. In treehoppers, this feature has undergone extreme evolutionary modification. Scientists studying evolutionary biology suggest that these exaggerated shapes are driven by natural selection, possibly linked to predator avoidance or communication. One hypothesis is based on visual deception. Predators rely heavily on pattern recognition. The unusual geometry of Bocydium globulare may disrupt this process, making it harder for predators like birds or spiders to identify it as prey. This aligns with principles studied in animal cognition and visual ecology, where irregular shapes can reduce detection probability. Another possibility is mimicry. Some researchers propose that the structure may imitate fungal growths or plant parasites, making the insect appear inedible or irrelevant within its environment. This is consistent with Batesian mimicry, a well-documented evolutionary strategy where harmless organisms imitate something unappealing or dangerous. Despite its intimidating appearance, Bocydium globulare is completely harmless to humans. It feeds on plant sap using specialized mouthparts adapted for piercing and sucking. Like other treehoppers, it may also engage in mutualistic relationships with ants. The insect produces honeydew, a sugar-rich liquid, and in exchange, ants provide protection against predators, an example of symbiosis studied in ecology. From a biomechanical perspective, the structure raises important questions. It appears fragile, yet it remains stable during movement. This suggests a highly optimized distribution of mass and material, something engineers study when designing lightweight but mecha-resistant structures. Even at such a small scale, physical constraints like gravity and vibration still apply. In the end, Bocydium globulare is more than just a curiosity. It is a living demonstration of how evolution can produce forms that challenge human expectations of design, function, and beauty.